So, hello guys, with the name of God, Ram Ram. Always start everything with the name of God, Ram Ram. Then no force in this world can stop you. Make God the center of your life. Now, guys, I am Kumar K. You must be knowing about me already. Still, I will open my LinkedIn profile one time. This is me, this is your lovely DSA plus OA plus CP mentor. This is me, Kumar K. Okay, you can check out. Okay, obviously, we are going to discuss and I'm going to announce, I'm very happy to announce that my student has cracked off campus 40 lp sd2 offer from PayPal and sd1 offer from Amazon. He was my personal one-to-one mentoring and daily life training student for 2 years. Initially he was not consistent, he was a total beginner in DSADF system design. After lots of teaching, lots of failures, lots of hard work, after 2 years he has done this. So make sure you check out this video so you can learn what kind of struggle and hard work you need to do in life to reach your final goal. And if you're interested in getting one-to-one mentoring from me for long-term mentorship and daily life training and course and referrals and all other features which we have, which are very special in itself, you can check out this link of training.daisyqna.in. Work so hard that I get the chance to feature you in my recent selection list. Now, let's go below. So, guys, we have to discuss Codeforces Division 2 problems, right? Round 1022. So, first, let's go with the problem A. So, guys, in this round is harder than usual. So, when people saw this problem, they did not know what to do. Okay. So, basically, they are saying that I will give you any permutation. You have to calculate the sum of the difference. That's all they are saying. So permutation is what? For n equal to, let's say, 4. Permutation is nothing but a set of numbers from 1 to n. Like 1, 2, 3, 4 is a valid permutation. Right? Then, you can say that 4, 3, 2, 1 is also a valid permutation. You can say that 3, 2, 4, 1 is also a valid permutation. Like this, many permutations are there. They are saying compute the difference. Compute the difference of these permutations with respect to 1, 2, 3, 4, and calculate the sum of the difference, and then tell me how many different sums were possible. For example, let's take n equal to 2. Let's take n equal to 2, right? Let's take n equal to 2. Which two permutations are possible? Well, 1, 2, and the next permutation possible is 2, 1. Okay. So, for 1, 2, what will be the answer? 1 and 2, and you try to calculate the difference. 1, 1, 0 plus 2, 2, 0. So, 0 is one possible difference. And what will be the difference for 2, 1? You write 2, 1 here and you write strictly increasing numbers 1, 2 here. Now, calculate the difference. The same thing, guys, same thing is happening here. You have to just calculate the absolute difference of pi minus I going from 1 to n, right? So what is the difference of 2 minus 1? 1. Plus what is the difference of 1 minus 2? Absolute difference. 1 minus 2 is minus 1, but you will not write minus 1. You will write absolute of minus 1, which is 1 itself. So guys, can you see for n equal to 2, we got two differences. If you take the permutation 1, 2 and subtract with 1, 2, you get 0. If you take permutation 2, 1 and subtract with 1, 2, you get difference 2. So I can write this whole ordeal, I can write this thing as, I can write this whole ordeal. Whatever I have made the observations till now, I can write it in a nice manner like this, that for n equal to 2, there are two differences possible. One is 2 another is 0. For n equal to 1, only one difference is possible because the permutation will only be 1. And difference of 1 when 1 with 1 will be 0. Now guys, let's say we have to find the answer of n equal to 3. Like to solve this problem in the exam, now you need to observe the test cases. See what's happening for n equal to 3. See what they're trying to explain you. Can you see the differences are always even numbers like 0, 2, 4. This gives you a hint. This gives you a hint. For n equal to 3, if you write like 1, 2, 3, 1, 2, 3, what is the difference? 0, 0, 0. So 0 difference is possible. This is the minimum difference possible for n equal to 3. What is the maximum difference possible? You write 1, 2, 3 in opposite order and subtract from 1, 2, 3. What is going to happen? 3 minus 1, 2. 2 minus 2, 0. 1 minus 3, 2. Absolute difference. 2 plus 0 plus 2, 4. So guys, minimum difference possible for the permutation is 0. 0 comes when you take 1, 2, 3 and subtract 1, 2, 3 with 1, 2, 3. And the maximum is when you write in reverse order. 4. Guys, it means all the even differences are possible like 0, 2 and 4. How am I able to do this observation? I can see for n equal to 1, 0 difference was possible. For n equal to 2, 0 and 2 is possible. For n equal to 3, 0, 2, 4 is possible. Can you see only even differences are coming? You only need to know the minimum difference and maximum difference, and all the even numbers in middle will surely be the answer. Done, done, done. Enjoy this life. You are not enjoying, you're taking too much stress. Learn how to enjoy and de-stress and declutter. You need to enjoy, de-stress and declutter. You need to enjoy, de-stress and declutter. Okay? It's very, very important for you. Declutter. Relax your mind. Okay? So, you are happy. I am also happy. Let's just chill out. Let's just chill out. Okay? Let's just chill out. Now, let's try to find the answer for n equal to 4. I know that the minimum answer will be 0. I want to find the maximum answer. If I know the maximum answer, all the middle even numbers will also come in the sum of the see, in some other permutations will generate the middle differences. So that's not a problem. What is the maximum difference possible? That's how I thought when I looked at the problem in the contest. So for n equal to 4, well, 1, 2, 3, 4. 1, 2, 3, 4. This is minimum, right? 0, 0, 0, 0. This is not a big deal. If you want the maximum answer, this 1 should be paired with this 4, and this 4 here should be paired with this 1. This 1 should be paired with the 4, and this 4 should be paired with the 1. Like our main permutation, this will be our 4. This is our main permutation, and this is constant here, 1, 2, 3, 4. Why am I pairing the biggest number with smallest number? Because if I pair the biggest number with the smallest number, the difference will be big, na? I want maximum difference. That's why I'm doing this trick. If I pair the biggest number with smallest number, 4 minus 1 will give 3 and 1 minus 4 will give us 3. Now you have to decide the middle part. See, you have gotten the maximum difference for the first index and the last index. Now how do you get the maximum difference for the middle numbers? You will say, sir, in the middle there is 2 and 3. So what should I write about 2 and 3? If I write 2 and 3 only, the difference will be 0 plus 0, not good. But if you write the reverse, 3 and 2, then the difference will be 1 here, 1 plus 1. So you have to write 3 and 2 basically, okay? You just have to write 3 and 2 and the difference comes as 1, 1, 3 plus 1, 4 plus 1, 5. Plus 3, 8. 8, guys. So all the differences we can come. 2, 4, 6, 8, like this. Can you feel it, baby? Can you feel it, bro? All we do is we know that the minimum difference 0 possible, maximum 8 possible. It means all the even numbers in middle will also be possible somehow. Because we can see that pattern. You don't need to explicitly prove it in the contest. But this much sense you need to put because this is a div to a problem. Cannot be that tough, right? Observe the pattern and just submit. Now you might be thinking, ki, sir, uh, like I know to get the maximum difference, the first number we take the largest and the second number we take the smallest. But how will we know what number should we put here? This is nothing but the same answer as answer of 2. Whatever was the answer for n equal to 2, same type of numbers you can put here. Why? For n equal to 2, what was the max answer? Answer of 2 is 2. Answer of 2 tells you what is the maximum even difference. How did this distance difference come to? You wrote 2 1 here, you wrote 1 2 here. This gave the maximum difference as 2, right? 1 minus 2, 1 plus 1. This answer for n equal to 2 can be replicated. For n equal to 2, you know that the answer was 2 1 1 2, and this was giving you the difference as 2. This same is applicable in this middle part. Can you see? Instead of 2 1, you will just increase one number more and write 3 2. Instead of 1 2, you will just increase one number more and you will write 2 3. And you'll get the difference. You just need to store what is the answer for n equal to 2. The final difference will be 3 plus 3 plus whatever was the maximum difference for length 2, because the middle part needs to be solved like that only, right? Like if I ask you, let's say n equal to 6, what is the answer, babe? The minimum is 0, maximum is, I will write 6 here, 1 here, 1 here, 6 here. What is the difference? 6 minus 1 5, 6 minus 1 5. Now I don't know how should I put the permutation, first permutation and the second permutation of n equal to 4 here. I don't know how to do that, baby. I don't know that. But I know that I've already calculated answer of 4. I know what is the best answer. I know what is the best answer. If someone asks me to, keep the 4 numbers in a way such that the maximum difference is coming. The best answer is 8, right? Best answer is 8, right? These same numbers you can keep here. The same numbers you can keep here. It is just that you want to keep the numbers 2, 3, 4, 5. So you will just add 1 to all of them. Add 1, 1, 1 year, 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 1 year. Adding 1 to both the upper and below number does not affect the absolute difference. So you will write these same numbers here but in the form of 2, 3, 4, 5. The answer of this was 8. So the answer of this whole part will come as 8. So 5 plus 8 plus 5. This is the maximum difference. Guys, 5 plus 5, 10. 10 plus 8, 18. Guys, if minimum difference is 0, maximum is 18, then all the numbers in the middle, 18 by 2 different sums are possible. 0, 2, 4, 6, 8, 10, 12, 30, 12, 12, 14, 16, 18. Now, guys, the final proof is, guys, sir, how can you guarantee that no matter what we do, the permutation, this, no matter what we do, this value, the sum of the absolute differences with the permutation, this value can differ only by an even number. So the sum will only get differentiated by an even number. So I will try to explain you the deep meaning of this. Like, nice deep meaning. The problem B is very interesting. I love that too. So lovely students. Let's say 4, 3, 2, 1. This is a permutation. Okay. What is the difference coming? 3, 1, 1, 3. If I swap, let's say I swap If I swap these numbers, the new permutation will be 4, 2, 3, 1. What will be the difference? 3, 3, 0, 0. Can you see? Earlier the difference was 3 plus 3, 6, 7, 8. Now the difference is 6. Difference has been decreased by 2, baby. Did you get it or not? It means that your difference of 8 can become 6, 6 can become 4, 4 can become 2, 2 can become 0. Done, 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 done. This is it. You don't need to try all the permutations. Just by doing smart swaps, it is possible to generate all the even differences from max difference to smallest difference. Yeah, you do not even have to prove this in the exam. You can see the pattern for n equal to 1 0, then 0 2 for n equal to 3 0 2 4. It is common sense, man. Anyways, even if you did a different kind of swap, the difference in the new answer would still be even. Let's say you do a swap of you swap 2 and 1, 4 3, 1 2, done 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 done. Difference is 3. Difference is 1. 1 minus 3 2, 2 minus 4 2. This was what? 3 plus 1 4, 3 plus 3 6 7 8. Now also after all this, the sum is 8. Can you see the difference of 0 has happened, which is a even number? So after all these proofs, you can like see that by the smart permutational stuff, you can always reach your answer. That's it. That's it. That's it. I would advise you to practice many of these permutation problems to get the gist of it. Now, guys, I have written the explanation here that whenever you make a swap I comma j to the permutation, sum increases or decreases by even number. So you just find out the minimum difference, which is 0, and maximum difference by the formula I told you, and your job is done. Like if I try to show you the coding, see, I just travel from, I travel from 1 to 505, right? I travel from 1 to 500. You know now what will be the biggest difference possible? The biggest difference will be what? I minus 1 into 2. Why? For n equal to 4, the biggest difference will be what? 4 minus 1, right? 3, and this 3. So 4 minus 1 multiplied by 2, right? This part and this part, and the middle part I already know as answer of I minus 2. So answer of I minus 2, answer of ID done. For every test case, you know the biggest difference. Biggest difference by 2 plus 1 is the total number of different unique even values including 0. And it's done. Now guys, let's go to the problem Uncle Z. CZ's and R. Anyways, guys, problem B is my favorite problem. Like, ZOR and OR. These are my strengths. I love it. I know it is a hell lot of casework, but I will tell you for the fundamental decomposition what kind of human thoughts you can put to solve this problem. Human thoughts are enough to solve this problem. Human thoughts, basic human thoughts. Trust me on this one. So, guys, you need to know some ZOR concepts, okay? So, like, if I try to explain you some ZOR concepts, the problem is done. I just need to know some ZOR concepts. So, if you don't know the ZOR concepts, you can check some of my prerequisite videos from the bit manipulation playlist. The ZOR of two same numbers is always 0. The ZOR of two same numbers is always 0. And if you write a number even number of times, na, if you write any number even number of times, okay, if you write any number even number of times, let's say 5 or 5 or 5 or 5, you know that the ZOR of two number is 0. ZOR of two number is 0. So 0 ZOR 0 will also be 0, na. So if any number is written even time and they are telling you to do the ZOR of it with itself, final answer is gonna be 0, bro. Okay. Another observation of ZOR is that a number can be written as the summation. See, A plus B is A XOR B plus 2 times A and B. Make sure this concept goes deep in your head. Very, very deep it should go, or else you are done. Okay. So A XOR B plus 2 times A and B. So you guys understand these basic things, right? I also understand and I rejoice in them and I love them. Trust me, trust me, trust me. See, if I ask you XOR now, 1 XOR 0, 1, 0 XOR 1, 1, 1 XOR 1, 0, 0 XOR 0, 0. So, if I tell you, give you two numbers and I tell you it's XOR, ask you it's XOR, answer will be 0 0 1 0 0 1 0 0. Okay, but guys, you can represent the sum of two numbers as the XOR. How? Let's say 1 0 1 0 0. This can be written as 1 0 0 0 0 XOR with you. This can be written as this number XOR with this number XOR with this number will give this as the output. So 0 0, here 1 was there, so 0 XOR 1 1, 0 0 0, 0 XOR 1 1. So you can say that 1 0 0 0 XOR 0 0 1 0 0 is giving you 1 0 1 0 0. But guys, you can replace this XOR with a plus operation, still it will hold true. 1 0 0 0 0 plus in binary, yeah, in binary 0 0 1 0 0. If you add also, then also the answer will be this only. So if a binary number has two ones, you can write them separately like this. One, like this was a 1 year, so I wrote this 1 year 0 0, all the other numbers 0. Then there was 1 year, I wrote this one as here and all other 0. If I add them, then also this will be the answer. If I XOR them, then also this will be the answer. So this is the special trick. For example, this can be written as XOR of three numbers. Which three numbers? First you take this one and write all other 0. Then you take this one and write all other 0. Then you can take this one and write all others as 0. This XOR this is nothing but this. You can represent this with plus sign also. This plus this plus this. Here the plus and XOR are doing the same job. Why? A plus B is equal to A XOR B plus 2 times A and B. But A and B is 0. A and B is 0 in this case. So A plus B is becoming equal to A XOR B. Why is A and B 0? Because in each of these numbers you can say at no two places one is matching. If there is one here, there is no one here. Okay. If there is one here, there is no one in the other numbers. If there is one here, there is no one in the other numbers. That's why the matter is totally, in our favor. Not screwed up, it's in our favor. So hopefully you understood that I give you any number, you can represent it as a XOR of some other numbers by using the one property. For example, 1 0. You can just write it as first this one, right? One, and if you consider this one, then all other you need to write 0 0 0 0 0. XOR. Then I will consider this one. All others I need to write 0 except this one. So 0 0 1 0 0. This or this will give this. But the nice thing is you can write this or as a plus sign also in this case. And this is the basis of the full solution, because this plus this will also give you this only. You know, na, this is 2 ki power 0, this is 2 ki power 1, 2 power 2, 2 power 3, 2 power 4. Great job. Done, 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 done. Now, listen to me, baby. Listen, listen, listen. They are saying that you have to construct an array of size n such that the XOR of the numbers of the array is x. So guys, this is an easy problem, right? Like I give you, let's say I give you x equal to 5. You have to construct an array of, let's say, size 7. So guys, how will you construct an array of size 7 such that the XOR is 5? 1, 2, 3, 4, 5, 6. This is the seventh place. Use your brain and tell me. God has given you the brain, so I know you will tell me the answer correctly, right? X is given to you as 5. You can represent 5 as binary like this: 1, 0, 1. What numbers to write in these 7 places so that the XOR comes as 5? Are you can write any number y na. Let's take any number y as 100. 100, 100. This size is odd, so I will write 100 even number of time. Guys, 100 if I write even number of time, what will be there? XOR. XOR will be 0. Now I write the 5 in the end. So 0 XOR 5 will be what? The XOR of this entire content will be 5 only. Why? Because 100 has come even times. Even number, if you write some number even times, its XOR is 0. Then there is a 5. So 0 XOR 5 will be 5. So this is one possible answer. But guys, they are saying they want the minimum numbers in the array. They want the sum of the array to be minimum. Now what will you do? Will you sit and cry, baby? No, 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 no. You don't need to sit and cry. You're a Kumar ki student, man. Be brave. You can do it. Array instead of 100, write a 1 there, na. 1 will make. Currently, what is the sum of the array? 100, 200, 300, 400, 500, 600, 605. 605. I want this number to be smallest number possible. This is not the smallest number. What will I do? Just rejoice and bask in the glory, man. I will write 1 instead of all these hundreds. Ram Ram. So for n equal to 5 and sorry, not n equal to 5, n equal to 7. Let's say n equal to 7 and x equal to 5. You want the XOR as 5, right? It is clear that we are discussing the case when n is odd, okay? Now, listen to me very carefully, okay? So what I'm trying to say, lovely students, is that n is odd, right? So the best answer is 1 year, 1 year, 1 year, 1 year, 1 year, 1 year. Why is this the best answer, guys? Why is this the best answer? This is the this is the best answer because, guys, because 1 is coming even number of times. XOR is 0 and I will write a 5 here. So now the sum will be 5 plus n minus 1. N minus 1 is what? 6. 6 plus 5, 11. This is the best answer. So whatever XOR you want, na, whenever your n is odd, whatever XOR you want, na, you write this 5 here. Okay. And rest of the numbers you write as 1. 1 is coming even time, their XOR will be 0. 0 XOR 5 will be 5. So we have reached the XOR as 5 and the sum of the numbers is also very, very small. Like n minus 1 numbers are filled with 1. So n minus 1 into 1 multiplied by x. Okay. But here comes the interesting case. Let's say that n is odd again. And let's say x is 7. 7 looks like this. 1, 1, 1. What you will say that, sir, let's do this. You want 7, right? You will write 7 here. 1, 1, 1, 1, 1, 1. You will say that the answer is n minus 1 plus 7. N minus 1 plus x is the answer. That's what comes to your mind, right? 6 plus 7, which is 6 plus 6, 12, 13. And you go ahead, right? So simple, right? Whenever n is odd, you know the even numbers, even places you write all the ones. There's or will be 0, 0 or 7 will be 7, and the sum will also be minimum. But guys, this test case fails. This test case fails. Unfortunately, this test case fails. You don't need to cry. We can solve it. You can do the distribution of 7. You know one possible case already, right? One possible case is this. I told you, right? You can distribute this as the XOR and summation of multiple numbers. Triple one can be written as triple one can be written as 100 XOR 010 XOR. I taught this in the past. 001. Or you can write it as 100 plus 010 plus 001. So I will write it like this. See, last number I will write it as 001. Second last number, the seventh number, sixth number I will write as 010. The next number I will write as 100. Now only four numbers are remaining. 1, 2, 3, 4. Now guys, in the remaining numbers I have no other options because I have decomposed it properly. So I will write 1 year, 1 year, 1 year, 1 year. Now the answer is better than the past. Why? Now the answer is, earlier the answer was coming as 6 plus 7, 13. Now only 4 times you have to add 1. 4 plus 1, 2, 3, 4, and this sum of these numbers is 7 only, because you know 100 plus 010 plus 001 is nothing but 7, and the XOR of these numbers is also 7. XOR of these number is 0, XOR of these number is 7, so the total XOR is 7. Also the sum of the last three numbers is also 7, because you know that the triple one can be written as XOR of these three numbers plus the sum of these three numbers. So XOR and the sum is both 7. So 4 plus 7. Oh my god, this solves the whole freaking problem. So guys, the lovely solution is pretty simple. Like, you can do it even when your eyes are closed. Let's say, let us say that you know what to do, right? The answer is nothing but like earlier one possible answer is what? One possibility is n minus 1 plus x. Another possibility is what? This is possibility 1. Another possibility is what? N minus u plus x. Why? Why is this the case? U is nothing but the number of set bits. Count of set bits. Count of set bits. How many ones are there in the number x? Because depending on the number of ones, those here, how many ones are there? Here there are 3 ones. It means you can take the last 3 positions and distribute it like this. And the last 3, the sum of the last 3 numbers and the XOR of the last 3 number will be x only. So now you only have to put, if u is 3, you only need to put n minus u ones. N minus u ones. U was 3 here, right? So n minus u plus x. What is n? N is 7. U is 3. 7 minus 3 plus 7. This 4 plus 7, okay? So guys, basically no matter what I give, you just need to know how to distribute and your job is done. For example, let's say your x was something like this. And your n is 7. What will you do? You will calculate the u. I'm taking this x in binary, huh? You can convert this like 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. What is 2 raised to 5? 32. This is 31. X is 31. What you can do is you can decompose these, right? You can take this one and you can write it here, right? You can write it as 5 numbers, right? 1 like this, plus, and you can replace these signs with XOR also, does not matter. So how many 1, 2, 3, 4, 5. 5 places it will take. 1, 2, 3, 4, 5. You will put these numbers here. Rest of the numbers I will fill with 1. So the answer will be n minus u plus x. N is what? 7. How many ones I have filled? 5. So the remaining 7 minus 5, 2 places are filled with 1, plus the sum of the 3, 4, 5, 6, 7. The sum of these guys will be x only, 31, right? 7 minus 5 plus x, 31 will be the answer. So guys, this is the solution for problem B. Okay. This solution will always work. Will always work when the number of set bits is greater than equal to 2. Guys, this case you have to remember, huh? The number of set bits, like x should, if you convert x into binary, it should always look like this. Something like this. If x is a 0, this will not work. And if x has only single one, then it can be rather confusing. Na? You don't know how to decompose it. If there is only a single one, you only know one answer, right? What you can do? You can write this number in the end and all other numbers with 1. This is one possible answer, but there might be a better answer than this. So better be careful. The good thing in this problem is that they explained all the test cases, or else it's it can become a due to D also if they don't write all these test cases. Okay. So this works nicely when the binary representation has at least two ones. This is called as a set bit. The count of set bits should be greater than equal to 2. If there is only one set bit, for example, if x is a power of 2 like this, then one possible answer is what? N minus 1 plus x. Why? Because now you can only write this number. Only single one is there. You can write this number in the end. Rest all the numbers will be 1. This is one possible answer for sure. For sure. But there might be a better answer also when there is only a binary, single binary number going on there. Okay, so you need to be ultra careful about that. Okay, and when n is odd, also see when see if it is like this. Let's say your x is either 2 raised to 1 or 2 raised to 2 or something like this. So either it looks like 1 0 or 1 0 0 or 1 0 0 0 or something like that. You get it, right? You get it. Let's say it's like this and your n is odd. Your n is odd. You can just declare that, bro, I don't want extra stress in my life. My n is odd. I know that even number of ones I can put here. So n minus 1 I will put here and this number I will keep in the end. Let's say it is 1 0 0. So n minus 1 plus x will be the answer. But what if your n is even? Now guys, I want to discuss some case with you. The another case is n is even. N is even and x has only set bit is only 1. Means x is either 2 raised to 1 or 2 raised to 2, something like that. Now what will you do? Will you sit and cry? N is even. Even means let's say n equal to 6. And let's say x is equal to 4. 4 looks like 1 0 0. So you will say, sir, 1 0 0, sir, I will put here, sir. And sir, rest of the numbers I will put 1 1 1 like this. No, this is wrong. Why is this wrong? Because now the 1 is coming odd number of times. 1 is coming odd number of times and you are screwed, okay? Because if 1 is coming odd number of times, its XOR will be 1. And 1 XOR 4 will not be 4. It means you need to represent 4 as the XOR of two numbers in the end. If your n is even, if your n is even and x is a power of 2 like this, only one set bit, you need to represent 4 as the XOR of two numbers. Guys, which are the two smallest numbers? 4 can be represented as 5 or 1. If someone asks you na, to represent a power of 2, represent a power of 2 as XOR of two numbers and the sum of two numbers should be minimum, the answer will always be 5 or 1. Why? Because you cannot use any number smaller than 4 to represent it, right? You need a number bigger than 4. So if you just 100, if you use a 5 it will look like 101, and you use a 1, then if you do the XOR it will be 4. So this is like a theoretical concept. If I give you any power of 2, let's say 8, and I tell you to represent it as XOR of two numbers such that the two number sum is smallest, the answer will be 8 plus 1, 9 XOR 1. So for 4 you will write here 5 and 1. So guys, 5 XOR 1 will give you the XOR as 4, and now rest of the numbers you can write as 1. So what is the answer? If n is even and x has only one set bit. If n is odd and x has one set bit, no problem. N minus 1 plus x is working. Why? Because even number of ones are there, na? But if n is even and x has only one set bit, what will you do? Will you cry? No, baby, listen to me. The answer will be, you can see, n minus 2 numbers will be 1. So n minus 2 numbers will be 1 because that will still be even, na? Plus two numbers. What will be those two numbers? One number will be x plus 1 plus 1. n minus 2 is here. 1 2 3 4. एंड x प्लस वन क्यों लिखना पड़ा? क्योंकि जो भी वो चार था उसको एक बढ़ाना पड़ेगा ना, x प्लस वन, और ये भी एक वन आ गया ना, 5 और एक कितना हुआ? x प्लस वन प्लस वन. So it is n plus x. N plus x is the answer. So this test case also we solved. Congratulations. And guys, so I hope the test cases you have understood till now, they are like this. If n is equal to odd, or we have the set bits greater than equal to 2. Set bits greater than equal to 2, then your life is already set. Why are you worrying so much? The answer is nothing but n minus u plus x. This is the minimum answer possible. But guys, it can sometimes happen that n minus u is becoming negative. If n minus u is negative, then the answer is just x. Why? Let's say n is equal to 3 and x is equal to 1 1 1 1 1 like this. So you can use 6 places to represent this x, but you have only 3 places. What will you do? Use this to represent this one, use this to represent this one, and rest of all the numbers you put in the first place. So the sum of the whole thing and the XOR of the whole thing will be x. Answer cannot be less than x. So if n minus u is negative, make sure you keep it intact. And guys, what if n minus u is not even? You want the n minus u to be even, na? Why n minus u to be even? Well, I will explain you one more test case. Let's take x as 1 2 3, okay? And let's take n as 7. You know it's 3, so it will take this place, this place, this place. Now this is what? This is n minus u. U is 3. This is even. Only if it is even, then you can put 4 times 1 to get XOR 0. But what if n minus u is odd? Then what will you do? Will you sit and cry? Let's take n as 6. Let's take n as 6. Now what will you do? You know this one will come here, this one here, this one here. Guys, now even is left. I cannot put 1 here 3 times. Okay. So now what to do? I cannot put here 1 3 times. Unfortunately, baby. Now what to do? Will I sit and cry? I cannot put 1 here 3 times. So what will I do? I will put the 1 4 times. I will put the 1 4 times. What will I do is I was representing this using 3 places. Now I will represent it using 2 places only. How? The sixth position I will write it as 1 and the fifth position I will write as double 1. So I can if it is taking 3 places now I can represent it in 2 places also. One number less. I can do that. Once that is done, now I have even places here, right? In the even places I will write 1 1 1. So if n minus u is odd, then the answer will be n minus u plus x plus 1. वाई प्लस वन क्योंकि तुमने एक जगह खुद के लिए बढ़ा दी ना. एन माइनस यू प्लस वन कर दिया तुमने. और जो बचा हुआ है वो वैसे भी एक्स. दिस विल ऑल्सो बी रिप्रेजेंटेड एज एक्स ओनली. You did a little bit conjuicy in distribution. So guys, if n is equal to odd or set bits is greater than equal to 2, you know what to do. Done, 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 done. But what if n is equal to even? N is equal to even and x is a power of 2 like 2 raised to 1 or 2 raised to 2 like this. You know the solution for this. This is also we have discussed. Now guys, the final test case which we need to discuss is what to do when x is 0. Guys, this is I am giving you as a homework. This is very easy. XOR can only come 0. You want the XOR as 0 and all the numbers should be positive. If n is equal to 1, then it is not possible. You cannot put a single number greater than 0 to get the XOR 0. Okay. And if the n is, let's say, even, then you can put one even number of time. But what if x equal to 0, n equal to 3 they are asking? Then the trick is to get 1 2 3. XOR of 1 2 3 is 0. And for x equal to 0, n equal to 5, what you can do is one more trick. One more trick which you can do, lovely students, done, is you can just be filthy rich and successful. This 1 2 3 which you learned, you write 1 2 3 and the rest of the even numbers you write 1 1 1 1. So the answer will be n plus, this 2 is doing plus 1, this doing plus 2, n plus 3 in general. So x equal to 0 case also solved. Now guys, the only leftover case is what to do. What to do if x is equal to 1? Why guys, x equal to 1 you cannot do the trick. Why? See, when x is equal to 2 raised to 1 or 2 raised to 2 na, you can do the trick of taking 1 1 and then do XOR with 1. 2 raised to 4 1 0 0 you can take 5 and do XOR with 1. But for x equal to 1 you cannot take a number greater than 1 like 2 and do its XOR with 1. The answer will not be 1 in the end. So if they are telling you that x is equal to 1, you want the final XOR to be 1. 1 looks like this in binary, 0 1. Now what will you do? Will you sit and cry? No, 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 no. If you compare all the options, you will come to know that your minimum stuff is going all right. For x equal to 1, if n is odd, the answer is simply n, right? You will write one odd number of times and the XOR will be 1. But what if x is 1 and n is even? You just need to be thinking of this test case and the problem is solved. Let's say n equal to 4, x equal to 1. What will you do? Just relax, just chillax, baby. Just relax and chillax, okay? So n is equal to 4 and x is equal to 1. What will you do? Well, you will just enjoy and relax. 1 2 3 4. Now you want the XOR of these things as 1. This I leave up to you as a homework. You can do a small trick and get the job done, by the way. Like, you cannot write all the ones. If you write all the ones, you're doomed. Let's take someone says n equal to 2 and x equal to 1. Do you know any two numbers whose OR is 1? Yes, sir. Which numbers? 2's OR 3 is 1. So you can write 2 and 3 is the best array. The sum is 5. And this was given in the first test case itself. This is the hardest test case, by the way. If they did not give this, everyone would fail the problem. So 2 comma 3. 2 plus 3 5. 2 comma 2's OR 3 is 1. So I will just write a 2 here, just a 3 here. Now the rest of the even numbers I will write a 1 1. So the answer is always this is plus 2, this is plus 1. So answer is n plus 3. MPNRC was a very famous website back then. Now guys, if I go through the code for problem B, like problem B is a deadly problem. It can be 1800 problem, but the people had lots of time and lots of test cases given, and you know, the Telegram, YouTube and stuff, you know what people do. So rather than that, this problem is a deserving problem to be a tough one. Okay, so like this was my code in the contest also. N equal to 1, this is a baby case. X equal to 0, you know what to do. Rest, if your bits, set bits are greater than equal to 2, and your this or this number is odd, it's n minus u negative this, or n minus u plus x, or n minus u plus 1 plus x. Done. Now the case comes when your x is a power of 2, x is a power of 2 and x is even. So n minus 2 plus x plus 1 plus 1. But if x is equal to 1, then the another possibility is n minus 2 plus 5, which is n plus 3, which is n plus 3. And this n plus x can still never be better than the odd cases. You can see here it was always n plus x minus u, and u was always 1. So that's why going in this case is better than going in this case when these situations are met, because this case is not possible in this case. Now guys, let's go to the problem. See, if n is odd, you can put n minus 1 in the array and the last number is x and declare answer as n minus 1 plus x. But you can do better by dividing x smartly and reducing the number of 1 in the array. Hopefully you got the main gist of the problem. Now guys, going to problem C. See, in problem C, I will now assume that the people who are watching this video have read this whole problem and they have understood it clearly. So guys, problem C is also pretty easy. Just chill out. They are saying that you need to travel the numbers in a decreasing order smartly. So how many guys you need to travel the array in a decreasing order? So guys, I have explained it here also. It should be understood that you have to make the journey in such a way that you travel from largest number to smallest number. The only problem in this question is that they have made a very messy language. The understanding becomes a little difficult. But the problem is actually simple, okay? You can do it. You just need to understand that you have to make the journey in such a way that you travel from the largest number to the smallest number. Okay, okay. It should be understood that you have to make a journey in such a way that you have to travel from the largest number to the smallest number. For now, we will take array only with distinct numbers initially to make it easy for you to understand. So guys, they are saying that you have to make some clones, and those clones can go anywhere, but they will only go in the continuous order. And you cannot click the buttons again and again, again and again. Please know that if you are at problem C, read this and understand this 1,000 number of times before going ahead with the video, because I cannot give the explanation of the problem. Okay, so like I am giving you the explanation, but making you understand deeply the meaning of problem is up to you. So let's do problem C. Where is the problem C? Okay, Jamboard. Become my successful student like this, man. Have some fun in life. Now, what the guy is trying to tell you is that they are saying that you have to travel the array in descending order. Travel the array in descending order. You need to go from largest number to smallest number. So think about it. From where will you start the journey? From where will you start the journey? You can think about it. You are a Kumar K student. बोल रहे हैं कि भाई साहब एरे को ऐसे ट्रेवल कीजिए, एरे को ऐसे ट्रेवल कीजिए कि भाई सबसे बड़ा नंबर पहले आना चाहिए, बाद में छोटे नंबर आने दीजिए। करिए करिए, आई गिव इट 1 मिनट टू यू, ऑल द बेस्ट। So what I mean to say is that you will create a clone one. Clone one will come here and travel 5. So guys, you can see that the clone one has traveled 5. So guys, इतना तो समझ गया ना कि भाई मुझे बड़े नंबर से छोटे नंबर पे जाना है. So you know that first you should travel 5, then 4, then 3, then 2, then 1. If you are looking at problem, see this common sense your brain has. I know God has given you this common sense. So first you will travel 5, then 4, then 3, then 2, then 1. Done, 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 done. Done, 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 done. So what I mean to say is that you have to travel 5, then 4, then 3, then 2, then 1. So first you travel 5. For the starting of the travel, you need to make a man. A man travels 5. Now this guy can only go to left or right. This guy can only go to left or right. This guy can only go to left or right, and you can guys mark it as used. This number has been used now. So clone 1 has visited 5 and 5 has been used. Can this 5 go to 1 in the left? No. Guys, you know that I have to travel from 5 till 1. First I have to travel 5, then 4, then 3, then 2, then 1. I created a man. That man has traveled 5. Now that man can only go to right or left. Right में क्यों जाएगा? उधर तो कुछ है ही नहीं, चोमू थोड़ी है. Man can go to left. But if you go to left, you fail the problem because after 5 you are visiting 1, not allowed. After 5, Windows reinstall. No. After 5 you need to visit 1, 1, 1. After 5 you need to visit 1. Sorry, after 5 you created a man. That man visited 5. 5 is marked as visited. Now you want to visit 4. Is it possible to directly jump from 5 to 4? No, sir, not possible. Why is it not possible to jump from 5 to 4? Because you can only travel one step to left or right. This is written in the question also. Like you can only go to left or right. Okay. So from 5 you can only go to 1, which is not allowed. So now you need to go to 4. So what will you do? You will create another man. You will create another man at C2. You will create another man at C2. You will create another man at C2. C2 can travel 4, na? Because I cannot jump, I just created another man who traveled 4. Now I need to travel 3. I can create another man and make it travel 3, but that is not needed. If you ever want to jump, guys, do you understand? If you ever feel the need to jump, you can create another man. This was the main observation. If you ever feel the need to jump, you can create another man. So that's what I'm trying to say. So guys, for 3, do I need to create another man? Can C1 reach 3? No. From 5 you cannot reach 3. No, 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 no. But can C2 reach 3? Yes. C2 has visited 4. It can go one step to the right. So C2 can reach 3. So guys, it can be seen that C1 has traveled 5 and C2 has traveled 4 and 3. Now you want some number to travel to. I can create new man to directly come and travel to, but is it possible without creating a new man? Because we want minimum number of men. Yes, C2 is at 3. Now C2 can come to 2. So C2 has traveled 2 also. C2 travel 4, C2 travel 3, C2 travel 2. 1. I can create a new man C3 and make it travel 1. But guys, is that needed? No. C2 is at 1, right? Now C2 can travel 1 also. So you can say that in the final traversal, C2 has traveled 4, 3, 2, 1, and C1 has traveled 5. So first we took 5, then 4, 3, 2, 1. See, we are getting the descending order. First came C1, traveled 5, then came C2, 4, 3, 2, 1. But if you wanted, you could have done like this also. You could have said that C1 will travel 5 and C2 will travel 4, 3, 2. This is a non-intuitive approach. Then you can say after that C1 will travel 1. So C1 traveled 5, then C2 traveled 4, 3, 2, then C1 traveled 1. So it is 5, 4, 3, 2, 1. The total order is in descending order only. Can you feel this? C1 traveled 5. Then a new man came. He traveled 4, 3, 2. Then C1 traveled 5. So the whole order is looking like 5, 4, 3, 2, 1. But this is unintuitive. What is the more intuitive approach? Intuitive approach is C1 came here. Then C2 traveled all the numbers 4, 3, 2, 1 in the decreasing order. So guys, this gives us some logic. What is the logic? If you are given an array of distinct numbers, you start traveling from the largest number, and that will solve your whole problem. Travel from the largest number. If you cannot reach the number, if you cannot reach the number, if you cannot reach the number by any other man, by any other man, if you cannot reach the number by any other man, introduce a new man, guys, and that solves the whole problem. So let's take a nice example. 781592. I know that I need to go in descending order. I know that I need to go in descending order. You can do it, guys. You can do it. Trust me. You need to go in descending order. You know that you want to travel 9, then 8, then 7, then 5, 2, 1. So, how will I travel 9? I'll create a man C1. C1 has traveled 9. Wow, 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 wow. Now I need to travel 8, baby. Now I need to travel 8. Now I need to travel 8. Can I directly go from C1 is at 9? Can I directly go here? No, you cannot do the direct jumps. So unfortunately, I will have to create another man to travel 8. I hope you got the gist of the algorithm, right? Yeah, that's it. If you are a person who is watching the video till C, I know you know these things, okay? So C2 is at C, okay, okay, okay. Now I need to travel 7. So how will I know if 7 can be reached by either C1 or C2? If a new number ever comes, if you ever feel the need to jump, you can create another man. If the current number can be reached by any of the existing clones, reach it without creating new clone. So guys, can I reach 7? See, this is yes, clone 2 will come here. Now I need to reach 5. Guys, I want some clone to reach 5. 9 then 7 then 8, कोई ना कोई क्लोन होना चाहिए जो 5 पे आ जाए. Yes. So guys, the answer is simple. If on the left guy or the right guy is used by some clone, if the left guy or right guy is used by some clone, then you can be reached by some clone. So C1 will reach here now. C1 will reach here now. Okay, so 9, then 7 could 8 could not be reached, so another clone 8 and then 7. 5, what do you do for 5? You check on the left and right. Is any clone there on the left or right? On the right there is a clone. I can use this clone and this clone can come here. Wow, 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 wow. Nice. Now I need to reach 2. I need to reach 2. How do I reach 2? You need to reach 2. The thing is that clones can travel in reverse order also. Clones can travel in the reverse order also. You know your clone 1 is at 5, right? Now the clone 1 can go like this and reach 2. Oh! Clone can go in the reverse order also. So for 2 you just need to check. Is there any clone on the right hand side? No, nothing is there. And for this, 2 needs to check, has the clone ever visited this number? If it is yes, it means clone can reverse and come here again. So guys, do you understand what the C1 guy is doing? C1 first traveled 9, then it traveled 5, then it again travels 9 and then it goes to 2. But this time the 9 will not be counted one more time. Why? Because the repeated numbers don't get counted in the sequence. It is written. Regardless, it can be pressed, but the buttons can only be pressed once. Okay, the buttons can only be pressed once. This was the main gist of the algorithm. That you go from 9 to 5. Now it means you can reach 1 or 2 whatever you want. Basically, मैं कैसे बताऊँ तुमको? If there is this subarray, let's say the clone C1 has visited all the guys from I to J. It means that now clone can visit J plus 1 or I minus 1. So if the clone 1 has visited this subarray, now it can do the reverse operations and it can reach anyhow, it can reach I minus 1 or J plus 1. This thing they did not nicely explain in the test case. That's why the submission for this are less, even though this is a easier problem than the problem B. So I will write here, if C1 has visited I to J, has visited the subarray from I to J, it means that in the next move, if C1 wants, it can go to I minus 1 or J plus 1. Okay. So hopefully you understood, guys. The deep meaning, the deep meaning is that the deep meaning is actually pretty simple. You must have understood by now that, this two, you just need to check the, for this element at index I, you need to check, is there any clone, has there been any clone in the past at index I minus 1 or I plus 1? If yes at any place, it means the clone can reach I also. So you don't need to create an extra clone. So you know that C1 has visited 9, then it has visited 5. It has visited this subarray. It means it can visit 1 and 2 also. But now I want 2. So yes, it will reverse. 9 to 5, it will again go to 9 and then it will go to 2. So yes, now the C1 has visited all these three numbers. So 9, 8, 7, 5, 2 done. Now what for 1? For 1, which clone? Array, for 1, this is the number I. What is the algorithm to check if the number I can be visited by some clone? You just need to check. Has any clone ever visited I minus 1? Or has any clone ever visited I plus 1? If yes, it means it can visit I also. Has any man ever visited I minus 1 or I? It means it can visit I as well. That's how you check. That is how you check if I can be visited by some clone. So guys, you understood these things, right? So guys, the problem is solved. You will just, if the array is having all distinct numbers, you sort the array, store the indices. Now you travel one index at a time. For each index, check is the I minus 1 or I plus 1 already visited or not. If both are not visited, increment the frequency by 1 and mark the current as visited. If either the left guy or the right guy has already been visited, then mark current as visited and don't increase the clone number. And the problem is solved in just one for loop and one sorting. But guys, what if there are repeated numbers? What if there are repeated numbers like 179 dun, 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 dun. So what if there are repeated numbers? Will I sit and cry? No, baby. No, no, no. What will I do? And how will I do? How will I do these things so these things go deep in my brain and I become super mega strong? Well. You are a Kumar case student, right? So you need to become a little stronger. Anyone watching my video is by default by my student. Now, guys, the thing is that you know that you have to travel 10, 10, 10, 10, then 9, 9, 9, 9. But you don't know in which order. There are multiple 10 na. Should I start with this 10 or this 10 or this 10? Which one? So guys, in the past also I taught you that if the clone has visited the subarray from I to j, it means it can travel I minus 1 or j plus 1. So guys, you can treat it as a subarray na. Treat it as a subarray of I to j. I to j. If you put a clone anywhere here, it can travel this whole subarray because all the numbers are equal, man. So guys, this all three tens you can replace it by a single 10 here. It does not matter. Whatever the tens which are there in a continuous format, you can replace them by a single 10. Does not matter at all. And whatever nines are in continuous fashion, you replace them by a single 9. So that is how you will solve this problem. Once this is done, you can then use any random order. It does not matter. Only the thing which matters is that if you take a subarray from I to j, if you take a subarray from I to j, if you take a subarray from I to j, if you take a subarray from I to j and your clones have traveled I to j, obviously if you make any one clone here, you put it here, it will travel everything here, right? So, but if let's say you after traveling these tens, let's say for the second largest number you take this guy, you will say that sir it cannot travel directly, it will have to jump, make a new clone. But no, it is increasing the clone count. You should have taken this index of 9, right, after all the tens are done, because these 10, the clone here can directly come to this 9. That's why I'm saying these all these nines you take it as single 9 and this as single 10. So now if you go clone 1 at 10, then clone 1 can go at 9. So let me explain you by one more test case is let's say this is the test case. So rather than solving this continuous fragment I'll convert to 8, this I'll convert to 9, this I'll convert to 10, this I'll convert to 9. Now you can do your regular algorithm. So the regular algorithm, when I'm doing it, I just need to calm down and just chillax. Guys, I think nothing is more important than the deep understanding. So always focus on the deep understanding in life. Just doing the problem is of no use. The deep understanding is the most important thing. The deep understanding can take you at such a higher level in life. So make sure you have a very deep understanding. Now what you will do? Clone 1 is needed for this, right? Yeah, done. Now you have to travel 9. Which 9 will you travel? Any 9 you can take. Let's take this 9. The order does not matter once you have clubbed all the equal numbers. So this 9 you take. No clone 2 is needed. This sub array is done. This also you can travel in just one clone done. So guys, hopefully you understood the problem. You understood everything. Always respect your mother and father. And now you have to work very hard. So guys, ABC is done. Make sure you check out our program link for the 850-hour DSA plus OA plus CP training. Please know that we have different batches for different people. Okay. We give day life training and we have 8-month cohort as well as 4-month cohort. So work very hard and get selected. We want your selection here. Okay. All the best and Ram Ram.